The first topic we're going to cover in section 3.1 is the product rule. What does the product rule say? The product rule says that if I have two functions that are multiplied, we'll call one f of x and the other g of x, then their derivative has to be affected by both. So we say then first we can take the first times the derivative of the second, f of x times g prime of x, and then we'll add to that the second times the derivative of the first, or g of x times f prime of x. And the way I learned this was I thought of these as first and second. So to me, this is 1 times, or the first, times the derivative of the second, plus the second times the derivative of the first. So you can memorize this rule as this rule for functions, or you can just memorize the little mnemonic that I use for that one. So for example, we have the function y equals 2x cubed minus x plus 1, that quantity times negative x to the 7th plus 8. So how will we find the derivative in this case? Well, much like we did before, we're going to say the first and second functions, or you can think of this one as f of x and this one as g of x, and it's a product of two functions. So our derivative y prime, which we can also say is dy dx, whichever way you want to write it, would be the first, so 2x cubed, minus x plus 1, times the derivative of the second, so it would be, I'm going to write it out this time, times d dx of negative x to the 7th plus 8, plus the second, which is negative x to the 7th plus 8, times the derivative d dx of the first, 2x cubed minus x and plus 1. So if we simplify a little bit, here we have 2x cubed minus x and plus 1, and then a derivative of negative x to the 7th plus 8 would be negative 7x to the 6th plus 0, because the derivative of 8 would be 0 since 8 is a constant. So that's it for that one. And then for the second term, we have negative x to the 7th plus 8 times the derivative of 2x cubed minus x and plus 1. And that derivative is going to be 6x squared minus 1. Because remember, 3 times 2 gives us the 6. Take 1 away from the power, drops it to 2. There's an invisible 1 here in front of the x, so when we lose the x, we're left with just the negative 1. So there's really not anything that we can factor out here. So we could actually leave it at this point. We could say this is our answer. Or if we really wanted to, we could multiply things through. So if I take a negative 7 times 2, I get negative 14 x to the 9th, because 3 plus 6, plus a 7x to the 7th, and minus a 7x to the 6th. And that one was kind of the easy one. This one on the second term, we're going to have to distribute. So negative x to the 7th times 6x squared would make it, I think I wrote a plus. I'm going to have to erase that to a minus. So let's try that again. So minus, because it'll be 6 times negative 1. So minus 6x to the 9th. And then negative x to the 7th times negative 1 makes it a plus x to the 7th. 6 times 8 is 48, so 48x squared. And 8 times negative 1 is negative 8. So if we start trying to combine some like terms here, we have negative 14x to the 9th minus 6x to the 9th. So that's a negative 20x to the 9th. Let's see here, what else do we have? We also have 7x to the 7th plus another one. So we'll have plus 8x to the 7th. And then the other terms don't have any matches, so minus 7x to the 6th plus 48x squared and minus 8. So this is the other form of our answer. I am okay if you leave it here at the first one, unless the directions say to simplify. If the directions say to simplify, then this is where you would end up. So this is if directions say simplify. Okay? Otherwise, you're fine leaving it in the first version. Let's try another example. For example 2, we want to differentiate the function h of x that equals x squared plus 3 times x squared minus 5 to the ninth. So I'm hoping you realize when we do a derivative of the second binomial here, since it has an exponent, we're going to have to use the chain rule. So this is going to be our first function, and this one will be our second. Or this is our f of x, and this is our g of x. So our derivative, dy dx, oops, we don't have dy dx this time because we have h, so it would be h prime of x. We can write it that way. Will be the first, x squared plus 3, times the derivative of the second. And this is where our chain rule, which we call the general power rule, will come in. We would have 9. We'd have our x squared minus 5 now raised to the 8th times the derivative of the inside, which would just be 2x. And then we would say, okay, let's add to that the second, x squared minus 5 to the ninth, times the derivative of the first, which is just 2x. So where things get fun now, and this is something I kind of warned you about, was that we're going to have to do a little bit of factoring. So in this case, if we look through, we notice that both terms have a 2x. So we're going to factor out a 2 and an x. So those guys are finished. Okay, what else does it have? Well, let's see here. They both have an x squared minus 5. And if you'll remember, let's take a quick walk down memory lane with factoring. If I said I've got 3x cubed minus 4x squared, we were able to factor that out by an x squared because that was the highest term they both had in common, and we were left with a 3x minus 4. What you notice here is that the limiting power was the lower one. So we're going to find the same thing here, where we're going to say, oh, 8 is lower than 9, so we're going to take out 8 of these. So we've got our 2x, and now we're going to take out an x squared minus 5 to the 8th. But where does that leave us in terms of what's still inside? Well, I took care of this one. I took care of this one. So what's left still on the inside here would be an x squared plus 3 times 9. And here I took care of the 2x. And I also took care of x squared minus 5 to the 8th. But this one says 9, so I have one more left over. So I have an x squared minus 5 to the 1. So if I simplify it all down together, I end up with 2x times x squared minus 5 to the 8th. And on the inside, if we distribute this 9, we end up with 9x squared plus 27 plus x squared and minus 5. And we can combine these x squareds, and we can combine the 27 and the minus 5. So our last step here would be to make it 9x squared plus x squared is 10x squared, and 27 minus 5 would be 22. So this would be our solution. So for these functions and for the directions here, we're going to say differentiate and simplify. And I will also say this is how Pearson wants it, and this is how we're going to want it on the exams. So make sure that you're factoring it out all the way. If you need some help on factoring, I suggest looking up factoring in Khan Academy. If you're not familiar with Khan Academy, it's amazing. They have videos, they also have activities, and you can even take short quizzes that you can then earn energy for, I think is what they call it, and which will allow you to earn badges and merits and all that kind of fun stuff. So if you're someone who likes to collect rewards, then it won't get you anywhere but get you badges on Khan Academy, but you can certainly be a person who can collect some of that information on Khan Academy. Let's try one last example and see how our factoring feels on these ones. So in this one, we have a function y equals negative x times the quantity 2x squared plus 3 raised to the fifth. So in this case, our first equation, our f of x, is just going to be negative x. And g of x, or our second function here, is going to be 2x squared plus 3 all raised to the fifth. So when we find dy dx now, our first is just negative x, and now our derivative of the second is where, again, we're going to apply the chain rule. So 5, and then we'll have 2x squared plus 3. Now to the fourth, we dropped it by 1 after taking the exponent down. And now we have to multiply by the derivative of the inside, which is going to be 4x. And then we'll add the second, which is 2x squared plus 3 raised to the fifth, times the derivative of the first. And the derivative of negative x is just negative 1. So turns out our factoring is probably going to be fairly simple on this one. It looks like if we just simplify it a little bit here, we've got what, negative 20x squared times 2x squared plus 3 raised to the fourth minus 2x squared plus 3 raised to the fifth. And if you'll remember from the last example, the power that's going to rule here is going to be the lower of the two, which is going to be the 4. So we're going to factor out this 2x squared plus 3 raised to the fourth. So if we take that guy out, 2x squared plus 3 raised to the fourth, I'm left with just the negative 20x squared on the first term. But the second one, I took out all but one of these guys. So I have minus another 2x squared plus 3 to the 1. Or we end up with 2x squared plus 3 raised to the fourth times negative 20x squared minus 2x squared and minus 3, which will give us 2x squared plus 3 raised to the fourth times negative 22x squared minus 3. Now you can leave it here if you want to pull out that negative. You can pull out that negative. I don't think that it's absolutely necessary, but if you really want to, you can make this negative, and then we would have 22x squared plus 3. You can factor that out, and then we'll just put the 2x squared plus 3 to the fourth after it. Also, a perfectly viable answer. I'm okay if you want to stop here. If you don't remember to take out the negative, I'm not going to kibitz with you on that one. So the next video is going to cover another rule of differentiation. This one was the product rule. The next one's going to be the quotient rule. I would like to leave you with an example that I want you to try before you go. And that would be, I want you to differentiate. So I want you to differentiate f of x equals x e to the x. But here's the thing, I want you to differentiate it twice. So I want you to find f prime. So I want you to find f prime of x and f double prime of x. So just a little exercise to help you practice a little bit with product rule, because your first derivative is obviously going to be a product of x and e to the x, but your second derivative is also still going to have an x e to the x term in it. So you'll have to use the product rule for that term again. So it's kind of cool. So I want you to try this problem, and if you've made it all the way to the end of the video, I'm going to have you do this problem, and I'm going to have you bring your solution, so bring the solution to class on Tuesday. All right? And then we will go over it from there. Okay?